Hello students, as per your physics book, the first chapter of your class 12 syllabus is electric charges and field. And Coulomb's law, which is one of the most important law of electrostatics that belongs to this chapter. Today in this video, we are going to discuss about Coulomb's law, as well as I will also explain the mathematical form of Coulomb's law. Let me first tell you that we know from the basic concepts of electric charges that there are two types of charges in nature. First one is positive and the second one is negative. We also know that there is a force between two charges. The nature of the force depends on the nature of the charges. If both the charges between which the force actually acts, if both the charges are taken as positive, in that case the force between the charges will be repulsive, they will repel each other. And if both the charges are taken as opposite to each other, that is, one is positive and the other one is negative, in that case the force between the charges will be attractive towards each other. That means one positive charge and one negative charge will attract each other. Now, what is Coulomb's law? Coulomb's law actually states the amount of force that acts between two charges. There are so many examples, there are so many experimental way by which you can verify is there any kind of force or not. If you take a simple comb and if you rub it on your hair, you will find that after rubbing, the comb can attract some small pieces of papers by which you can verify that there is definitely a force of attraction between two charges, as by rubbing the comb there are some charges gained by the comb that may be positive, may be negative. If we consider that the comb gains some positive charge and when it takes and when it is taken towards and when it is taken in the vicinity of some small paper pieces, by the method of induction it attracts the paper pieces. However, we experimentally can verify the force between two charges. Now, what is Coulomb's law? Coulomb's law actually states the amount of force between two charges. Let me explain the Coulomb's law by a diagram. Consider that there are 2 point charges. One is Q1 and the other one is Q2, and the distance between them is R. Now, according to Coulomb's law, the force between the charges F is directly proportional to the product of the charges, that is Q1 and Q2. It is also proportional to the square of the distance between them. Actually, it is inversely proportional to the square of the distance between them. That is, we can say that F is directly proportional to 1 by r square. As it varies as 1 by r square, that is why sometimes Coulomb's law is called inverse square law of force. Now, by combining these two equations, we can write that F is directly proportional to Q1 Q2 by r square. We all know that to remove that proportionality sign and to bring a equal sign, a constant should be taken. Let that constant is equal to k. Therefore, we get F is equal to k into Q1 Q2 by r square. This is the mathematical form of Coulomb's law. So, from this mathematical statement, we can demand that the force between these two charges, the force in which direction will act. Now, from this mathematical equation, we can demand that the force between these two charges is directly proportional to 1 by r square. That is, the force depends on the distance between the charges, as well as it also depends on the amount of charges. Now, we know that force is a vector quantity. So, we should consider the direction of the force as well as its magnitude. Now, if both the charges are taken as positive, that is, if we consider Q1 and Q2 as positive charges, in that case the force is repulsive, as I have told you earlier. So, the force on Q1 will be directed in this direction. Let the force on Q1 due to the charge Q2 is F12, and it is a vector quantity, that is why a vector sign should be applied. And the force on Q2 is directed in this direction, as it is a repulsive force, and it can be denoted as F21. Now, if we write this equation in a vector form, then we can write F12, that is the force on Q1 due to the charge Q2. F12 is equal to K into Q1 Q2 by R12 square. Actually, that R12 is nothing but R12 modulus of R12 is equal to R, which is actually vector R12 divided by the modulus. As there is a vector sign on the left hand side, so there should be a vector on the right hand side also, and the direction is R12. Similarly, the force on Q2 F21 can also be written as K into Q1 Q2 by R21 square multiplied by the unit vector R21. Now we know that R21 can be written as vector R21 divided by the modulus of R21. Now we know from vector algebra that, there should be unit vector. Now we know from vector algebra R21 is equal to minus R12. Therefore, F12 is equal to minus F21. From this equation, we can say that Coulomb's law satisfies Newton's third law of motion. Now, let me introduce one more fact, that this constant, what about this constant, K? Actually, the constant depends on the system of unit. There is a certain value of K. In CGS unit, the value of that constant is 1, and in SI unit, the value of the constant is equal to 1 by 4 pi epsilon naught. Where epsilon naught is free space permittivity, the value of epsilon naught is 10 to the power minus 9 by 36 pi and having the unit of farad per meter. So, this is a basic discussion on Coulomb's law.